Okay, now that we've talked about the requirements in order for us to be able to perform a hypothesis test using a standard normal Z distribution, let's look at the test statistic, because this is something that also differed from our last target where we talked about the test statistic for a population mean. It's still the same general formula. Our test statistic is going to be equal to our statistic minus our parameter. This parameter we're going to get from the value of the null hypothesis divided by our standard error. Okay, so for testing a hypothesis about a population proportion, we're going to go ahead and use a test statistic that is a Z from a normal Z distribution. You're going to take p hat, that's what you calculate from your sample, minus our hypothesized proportion, divided by the square root. Now this is what people sometimes get wrong, because when we did confidence intervals, we weren't estimating what p hat, or excuse me, what our population proportion was. We were just saying we were creating an interval that may contain it. Well, for this, we're hypothesizing, in the null hypothesis, we're hypothesizing our proportion or population proportion to be some value. So we're going to use that here and here. So again, be careful of that. That's one of the biggest mistakes people make, is that for these two values right here, they use p hat and not the hypothesized proportion from our null hypothesis. Okay? So again, I kind of got sidetracked there a little bit. You're going to take p hat minus your hypothesized proportion divided by the square root of your hypothesized proportion value times 1 minus that hypothesized proportion value divided by your sample size. And then we go ahead and put this, and we will put this on a normal Z distribution. Again, we use P naught from the null hypothesis, H naught because it is assumed to be true. Okay? Now, once you've calculated that test statistic, Z, we go ahead and we're going to graph it using our stat app, Artistat app. We're going to be on a normal distribution, okay, not a T distribution, a normal distribution. And the thing is, when you're on this normal distribution, you're looking at, it says mean and standard deviation, even though we're using p hat, ladies and gentlemen, or excuse me, even though we're using a proportion, keep this at 0, 1. Do not change this, because when you compute your test statistic, we're going to put that on a normal Z distribution, okay, a standard normal Z distribution. So for a standard normal Z distribution, the center of this distribution has to be 0, as you can see right there, and then it has a standard deviation equal to 1. So do not change that, okay? That's the nice thing about this. Those stay the same. You don't have to worry about changing those to p hat or anything like that, okay? This right here, whether it's a lower tail, which is less than, an upper tail or right tail, which is greater than, or a two-tailed test, that just all depends on, ladies and gentlemen, again, where your test statistic, what the value of your test statistic was. If it was positive, it's going to be a right test. If it's negative, it's going to be a left test. Don't worry about two-tailed tests with respect to having this right here. It's either going to be upper or lower, depending on which tail your Z statistic is in. And then that's going to be the value you found of your test statistic. Okay? So it's somewhat similar to what we did last chapter. So now that we're done discussing, how the setup of this works, the rest of the steps will be the same. Let's go ahead and look at a couple examples, all right? And these will be on your student example sheets that I sent to you.